Hi guys, how are you? I hope you are doing well. So in this section 8.1, we want to estimate the population mean, mu, when the standard deviation sigma is known, okay? So we don't know the population mean mu, okay? But we do know the standard deviation. And we want to estimate the population mean mu, right? But to estimate the population mean mu, we need actually a random sample of size n, okay? So actually the distribution here, the distribution is normal. The distribution of the variable x is normal, or the size of the sample is large enough, or n is large enough. Okay, so this either distribution is normal, the distribution here is normal, or n is large enough. Okay, so then, because n is large enough, we can use the central limit theorem, and then we get a normal approximation of the distribution. Okay, now, so we have this random sample. So because you have this random sample of size n, then we know x bar, the sample mean. So we know the sample mean x bar. Okay, so it's the sample mean. It's not the average of the entire population, but it's just the average of the sample, right? So we want to estimate. The population mean mu, right? And so the idea is we want to find an interval estimate of the population mean mu. Okay, so we know the sample mean x bar, and we want to estimate or find an interval estimate of the population mean mu, right? So we're gonna try to estimate mu, and this interval estimate of mu is called the confidence interval. So the interval estimate of mu is called actually the confidence interval. Okay, so it's called the confidence interval. And let's say you want, for example, we want to find a 95% confidence interval of mu. That means, this means actually that the probability that mu belongs to the interval is equal to 95%. So that means that mu, the value, or the probability that mu is in the interval, the probability that mu is in the interval, or mu belongs to the interval, is 95%. So when you say 95% confidence interval, it means that you are certain, 95% certain that the mu belongs to the interval. Okay, or if you say 99 confidence interval, it means that you are 99% certain that the mean belongs to the interval. Okay, so now the big question, of course, so how do we So how do we find this confidence interval? Okay, so the confidence interval has the following formula. So the formula is the following. So the confidence interval is actually given by x bar. So the interval is given by x bar. So that's the sample mean, right? Minus e. So e, that will be actually, I'm gonna explain later what's e, but e, it's the maximal marginal error. Okay, and I'm gonna give you a formula for e. Okay, so x bar minus e, x bar plus e. So what's e? So what's e? Well, e is called the maximal marginal error. Okay, and E actually is equal to z score sub alpha or index alpha times sigma over square root of n. So here sigma, of course. So here's my interval of confidence. It's x bar minus e, x bar plus e, and capital E, that's the maximal marginal error, and it's equal to this z alpha. I'm gonna explain what's z alpha times sigma, of course, sigma. So sigma, that's the standard deviation. It's known, right? N, so sigma over square root of n, that's the size of the sample. Okay. And so then this z alpha, so this z alpha, it's called the critical value and depends on the confidence interval. So, so let me explain how. So how do we compute this critical value? Okay. So now the question is, how do we compute this critical value? But first, let me show you some examples. So here, there's a table here for examples here. So if you say so if you say, for example, 95% confidence interval, so 95% confidence interval, okay, then this z alpha would be equal to, or z sub alpha or z index alpha is equal to 1.96. Okay, so then the error e, the maximal error e is equal, of course. So then e is equal to z alpha, which is, so it's 1.96 times sigma over square root of n. If you want to find, let's say, 99% confidence interval, then this z alpha would be equal to 2.58, and the maximal marginal error e would be equal to 2.58 times sigma over square root of n. And let's say another example, and I will show you later how to find this z alpha for for any percentage of confidence interval. So here, let's say here 90% confidence interval. Okay, then this Z alpha is equal to 1.645. Okay, and so the error E would be 1.645 times sigma over square root of A. Okay, so before explaining how to get this Z alpha or this critical value alpha, so let me do an example, a numerical example here. Example. So let's say Walter likes jogging. Okay, and from past experience, let's say he knows that sigma, the standard deviation, is equal to 2.40 minutes. Okay, for his so the standard deviation for his jogging time is actually 2 minutes, 0.40. Okay, so sigma is 2.40 for his jogging time. Okay. Let's say now, so he doesn't know what's the average of all his jogging sessions. Okay, but he knows that actually the standard deviation for all his jogging sessions is 2.40. Okay, now he took a random sample of 90 jogging sessions. Okay, so for a random sample of 90 jogging sessions, the mean time, so X bar is equal to 22.50 minutes. Okay, so now we want to find, so let mu be the mean, so the population mean for all his jogging sessions. Okay, population mean for all his jogging sessions. Okay, so let's find, let's say, 99% confidence interval of the population mean mu, so the mean of all his jogging sessions, right? So let's see. So here's this problem. First, we know the standard deviation. So sigma, so that's the standard deviation, right? And we know it's equal to 2.40, right? That's the standard deviation. We have a random sample, right, of 90 jogging sessions. So 90, that's the size of the sample. So that's n. Okay, so this is n here. Now we know that Walter knows that the sample mean, or the mean time of all the 90 jogging sessions, X bar, it's 22.50 minutes, right? So now we're gonna try to estimate mu. So we're gonna try to find the confidence interval, 99% confidence interval of mu. Okay, so we want 99% confidence interval of mu, right? Of mu. So 99% means, so now let's just come back to our table. So 99% means that, here's 99% confidence interval, right? It means that Z alpha is 2.0 2.58, then it means that the error E, the maximal marginal error E, is 2.58 times sigma over square root of n. Okay, so 99 means that this Z alpha, this critical value is actually equal to 2.58. Okay, and so the error E, okay, is supposed to be equal to so it's supposed to be Z alpha, right, times sigma over sigma, the standard deviation sigma over square root of n. So Z alpha, we said it's 2.58 from our table, times sigma, the standard deviation here, it's 2.40. So it's times, so 2.58 times 2.40 over square root of n, and n is 90, right? So it's square root of 90. So that will be equal actually to 0.65. Okay, so then the answer here, the confidence interval, so the 99% confidence interval is supposed to be x bar minus E, the error, the maximal marginal error, x bar plus E. So now, so what's x bar? X bar, here's x bar. X bar, we said the sample mean is 22.50, right? So it's 22.50 minus E. E is just this 0.65, so that's E, so minus 0.65, and then 22.50 plus 0.65. So then that will be equal to 21.85 and 23.15. Okay, so what does it mean, this answer here? What does it mean, this interval, 21.85, 23.15? So it means that we are 99% certain that the population mean, that mu, so that's the mu, that's the mean of all his jogging sessions, not just the 90 jogging sessions, but for all his jogging sessions over the last years. Okay, so then that mu is, so mu, that's the population mean. So we are 99% certain that mu is in the interval 21.85. So the average is between 21.85 minutes and 23.15 minutes. Okay, so we are 99% confident that the population mean, that the average of all his jogging sessions over the last years is in the interval 21.85 minutes and between 21.85 minutes and 23.15 minutes. Okay, so that's an example. Now guys, let me show you how to find, so here the remaining question is, in general, so in general, how do we find this critical, the Z alpha? Okay. Well, so I mean, in practice, guys, again, if you have a problem and you want to find the interval, the confidence interval of population mean, and let's say it's 95%, so you don't have to do anything. You can just use this value here. So if 95%, then you know that Z alpha is 1.96. If it's 99%, then you know that Z alpha is 2.58. If it's 90%, you know that Z alpha is 1.645. But in general, how does it work? Well, so let's say So let's say you want to find, so we want to find the Z alpha of 1 minus 2 alpha 100% confidence interval. Okay. So, for example, if you say if you say 95% confidence interval, okay, so it means that 1 minus 2 alpha 100% is equal to 95%, right? So of course, so this is 100%, so then 1 minus 2 alpha is equal, so this is 0.95, of course. So 1 minus 2 alpha is 0.95, right? So let's subtract here. So then let's subtract 1 minus 95, 0.95 minus 0.95, and then plus 2 alpha here, plus 2 alpha here, right? So then it means that 1 minus 0.95 is equal to 2 alpha, of course, okay? Now, so what would be alpha in this case? So 1.095% is equal to 2 alpha. That means that 0.05 is equal to 2 alpha. It means that, so you divide by 2, of course. So this alpha here would be actually 0.025. Okay. So what's the interpretation of this 0.025? Again, guys, so this is a 95 confidence interval of the population mean mu, right? So we have your distribution here. This is your distribution. And so the probability that mu, so here's, let's say, here's your population mean. So the probability that mu is in the confidence interval is 95%. And 95%, so the 95%, that's the 1 minus 2 alpha, okay? So the probability that mu is is the confidence interval is actually 95%. So this is 0.95, which means that this area here, so your mu is in this interval. The probability that this mu here, the population mean, is in this interval is actually equal to 0.95. That's the 1 minus 2 alpha. So here this is here. So this is actually equal to 1 minus 2 alpha, which is the 0.95, right? And remember, guys, so the total area is equal to 1. So this is, here it's 1 minus 2 alpha. It means here, the area here would be equal, here, this area here, this is equal, this area here is actually alpha. Okay, and here it's the same, here it's alpha. Okay, because remember the total area is equal to 1. And actually your distribution is symmetric. So this is alpha plus 1 minus 2 alpha, that will be equal to 1. Okay, so here the total area is 1. Is 1, which is 1 minus 2 alpha. So that's the green region here. Okay, and here on the left we have alpha, so that's plus alpha here, and on the right we have another alpha, so that's plus alpha. So it adds up to 1, right? So the total area here is alpha. Now the Z alpha, this critical value, corresponds to this the Z score here, this one here. So this value here, this is your Z alpha, and here this is your, or minus Z alpha, sorry, here's minus Z alpha, and here the positive Z alpha. Okay, so what I'm saying, guys, is that the area to the left of minus Z alpha is equal to alpha. So this area here, which is equal to alpha, right? We said the area here is equal to alpha, is that's the area to the left of minus Z alpha. So what we are saying here is that the probability that the Z is less than minus Z alpha is equal to alpha. Okay. So in our example here, we said alpha is 0.025, right? So we started with the 95 confidence interval, right? The 95%, that's equal to 1 minus 2 alpha, right? And then we said, so then alpha is 0.025. So this alpha here is equal to 0.025. So what will be the corresponding minus Z alpha here? So now we have to check. So we check the table of the standard normal distribution. Okay, and you can see that so here, here's your Z here. So here, let's say you have negative 1.9 here. So this is to the 10th, here to the 100th. So here is let's say here is 0.06, and so this value here. So here you can find 0.025. Okay. So your minus Z alpha corresponds to, so minus Z alpha corresponds to negative 1.96. Okay. So then, of course, this is minus Z alpha. So then Z alpha is equal to positive 1.6. So this is why if you have a 95% confidence interval, right? If you have a 95% confidence interval, then your Z alpha, this critical value, Z sub alpha, the critical value is 1.96. Okay, so that's how we get the Z alpha. Okay, let's do another example. So let's say, so this is example 1. Okay, so let's say example 2. So let's say you have 99% confidence interval. So how do we find the critical value Z alpha? So again, 1 minus 2 alpha is equal to the 99%, which is the 0.99, right? So 1 minus 2 alpha is equal to 0.99. Okay, so then 1 minus 0.99 is equal to 2 alpha. Okay, so that's 0.01 equal to 2 alpha. You divide by 2. So then alpha is equal to 0.005. So that means that the probability that the Z score Z less than minus Z alpha is equal to 0.005. Okay, so again, here's your minus Z alpha. This is your Z alpha. Here's your mu, the population mean. Okay, so the probability that mu, the population mean, belongs to the interval of confidence is 99%. So it means that this area here is 0.99 here. Okay, and then to the left here, this is 0.005, and here to the right here, this is 0.005, right? Again, guys, remember it adds up to 1. The total area is 1. So here, this is 0.99, this is 0.05, and this is 0.005, okay? So what will be the corresponding minus? So here's minus Z alpha. So then minus Z alpha, if you check the table of this Z-score, okay, so then minus Z alpha would be actually, well, if you check the table, it's well, it's approximately minus 2.58. Okay, it's actually between negative. It's between negative 2.58 and negative 2.57, I think. But you take, of course, the most conservative value, so it's going to be negative 2.58. So then Z alpha, of course, would be 2.58. Okay, so that's why here in this table, I got, when you have 99% confidence interval, it means that this Z alpha is 2.58. Okay. So that's it, guys. I'm gonna stop here, and you can find more details and examples in the lecture notes. Thanks. See you next time.